Hi, this is N.K. Pandey. I am going to share second part of the questions on fluid mechanics. I hope questions might be useful for civil, mechanical and chemical engineers. Fluid mechanics subject is one of the core subjects for civil, mechanical and chemical engineers. For civil engineer, fluid means water, whereas for chemical and mechanical engineers, fluid means any liquid or any gas. Civil engineers deal with large flow system like open channel flow, dam, wastewater treatment, etc. Whereas a mechanical engineer deal with flow dynamics, CFD simulation, multi-phase flow, and chemical engineer deal with again multi-phase flow, CFD simulation, and flow in process equipment. The question being asked in interview basically are tailor-made and also depends upon nature of the job. Their focus basically is on fundamentals and they look for the basic knowledge of candidate in this regard. And I have noticed that uh, mm, around 70 to 80% of the candidate tell their favorite subject as a fluid mechanics because I had been in several selection committee for many years and I know what are the questions they ask during interview and what they expect from the candidate. So let us go through the questions. First question is, what are the forces acting on a particle moving in a fluid? Make a force balance diagram. So let us consider a particle is moving under the action of gravity and the forces acting on it are buoyant force acting upward, force due to gravity, and drag force, which is again acting upward. So, resultant force on the particle is given by mass into acceleration of particle equal to force due to gravity minus buoyant force minus drag force. How question number two? How to calculate pressure drop in a helical coil pipes having same length and diameter, in which case pressure drop will be more or pressure drop will be same in both the cases. Generally, helical coils are used for as a cooling coil to cool the processed liquid. So, in order to design a cooling coil, it is necessary to know how to calculate pressure drop in a helical coil. For this, you can refer any book or any suitable literature. Question number three, what is constant header tank? Generally used for feeding processed liquid to equipment under gravity flow. Normally, rotameters are used uh, to feed the any process equipment in order to maintain a constant flow rate. But over the period of time, as tank level comes down, rotameter reading requires adjustment or knob has to be adjusted in order to meet the constant flow rate. So other option is uh, this kind of arrangement is used. Uh, the tank is having two nozzle, one is top nozzle and one is bottom nozzle. Uh, when this valve is open, so some amount of liquid flows down, and this is connected to the atmosphere. So there's some amount of bubble through that liquid, and pressure at this discharge point is always uh, equal to atmospheric pressure. So that flow rate always will be same regardless of level of the liquid in the tank. Question number four. Suppose there are two concentric cylinder. One is stationary, outer one is stationary, and inner one is rotating. And inner cylinder is having hole, and when it rotates, it creates suction at the bottom where hole is there, and liquid is sucked through that and comes out. This is the inlet to this outer cylinder. The space between inner cylinder and outer cylinder is known as the annular space. And here this is a stationary surface and this is a rotating surface. Here no slip condition is applied, so velocity at this surface of this stationary will be zero, where the velocity of the fluid element will be same as the rotation velocity of inner cylinder. Now question is, what is the velocity profile in the annular zone of this chamber? Uh, Question number 5. Draw pressure and velocity profile along the length of a venturimeter and where manometer tappings are provided. So let us see venturimeter. This is a venturimeter and this is a throat. Converging, diverging nozzles are there, and here uh, this is a manometer tappings here, and one is at throat, uh, and it may be at top or it may be at bottom. One question generally being asked that manometer liquid level, what is the level in the upstream here, and in downstream. I have noticed around 20 to 30% of the candidate is not very confused and they are not very much clear about what is the level of manometer liquid in the manometer limb. Suppose where it is in this case downward, and it is when it is in upward tappings are there. Second question is, uh, draw velocity profile along the length of a rotameter, along the benchimeter, and pressure profile along the length of benchurimeter. Question number 6. How to calculate film thickness for a liquid flowing over a vertical rod of known dimension. Suppose this is a vertical rod having diameter d, a liquid is flowing over it. So there is a formation of film here or liquid layer on the surface of rod. So how to calculate the thickness of this liquid layer on the vertical rod? Generally, this is a similar to weighted wall column, which is used to estimate the mass transfer parameter. Data provided here is physical property, flow rate, and diameter of the rod. Uh, Question number 7. Define types of friction factors and how to calculate them. This uh, answer of this question you can find out in any standard textbook or in any suitable literature. Name any fluidic pump if you are aware of it. I think this question is out of syllabus because uh, information on this you cannot able to find out in any standard textbook. I have included here because to enrich your knowledge. So generally in industry, uh, mm, uh, centrifugal pump or any other pumps are used for the transfer of liquid from one place to the another place. But if liquid is hazardous in nature and the location is not appreciable to maintain the centrifugal pump or any other kind of uh, reciprocating pump, because that pump, centrifugal pump or any pumps are required some kind of maintenance because of it is a moving part or rotating part which requires uh, over a period of time some kind of maintenance. So in order to avoid that, fluidic pump are used to transfer liquid from one place to the another place. So here I will discuss two or three fluidic pump which are as follows. This is a cylindrical chamber and having two nozzles. One is a axial nozzle and one is a tangential nozzle. Difference between these two are actually this is called forward flow or low resistance flow path, and this is called reverse flow uh, or high resistance flow path. These are called diodes actually, and um, pressure drop in this case will be less than pressure drop in this case. So this question I have already mentioned in my previous video. Some part of it I have indicated there. One can refer it. So how these connections are uh, provided in order to transfer the liquid from supply tank to receiver tank is given here. This is a supply tank or feed tank, and this is a receiver tank. In between there is a pressure chamber, and here this one diode is connected here and one diode is connected here, and there is a connection, air connection is provided to pressure chamber, and initially this vent is open, so that liquid uh, from the feed tank is filled up in the pressure chamber, and after that vent is closed and the air is applied. So after application of air, so liquid uh, will come here in this, it will follow this path and will be transferred to the liquid. Most of the liquid will be follow this path, and little amount of liquid will go back to the supply tank, because in this case, it is a high resistance path. You can see here this is a tangential here entering. So this is a high resistance path, and when liquid is moving in this direction, so this is a low resistance path. So that's why uh, uh, more amount of liquid will flow in this direction, and a little amount of liquid will flow back to the tank. So this is one kind of fluidic pump. Another kind of fluidic pump is called RFD pump. This is called a diode pump, and this is called RFD pump, which is known as reverse flow diode. It is very similar to ejector. Uh, it is a converging and diverging nozzle type of arrangement here provided, and air is enters here. Air or any other fluid can be used. Enters here. That is called motive fluid, and when it is air is supplied, so at this point there is a creation of low pressure, and which sucks the liquid, and sucked liquid will follow along with the air and transfer to the receiver tank. The connection is given here. This is a feed tank here, and this is RFD. Uh, and this is a pressure vessel here, and air connection is provided to pressure vessel. Initially this vent is opened, so that liquid from the p tank is filled up here, and after that vent is closed and air is applied here, air, and that air pushes liquid, and in this section also is creation of suction here. So liquid, some amount of liquid from the feed tank, and here liquid will pass through that and transfer to the receiving tank. So RFD, this is called RFD tank. Fluidic pump having one advantage that it has no limitation of head. It can lift any amount of head, and there is no maintenance requirement. It is here no free of maintenance. So mostly being used in a process equipment, process industry, where the hazardous liquid has to be transferred from one place to the another place. Question number 9. So draw characteristic curves of a centrifugal pump, and how to choose a centrifugal pump for a given requirement. This is very frequently asked question, and uh, type of question on this they ask head versus capacity, flow rate curve, system curve, efficiency curve, and operating point, how to decide. So this you can find out in any textbook. Question number 10. This is also related to pump. What is cavitation? Describe NPSH available, NPSH required, and details can be found in any textbook. Uh, Question number 11. Define drag force and types of drag force. factors affecting the drag force. So drag force is given by this formula. This is a coefficient of drag, area, u, that is velocity square, and rho divided by 2. So question also they ask rho is density of medium fluid or particle. What is the area meaning here? What is the velocity of particle or velocity of fluid? This is CD. What is the value of CD and how to get the value of CD? This is the third type of fluidic pump, airlift, also used in a process industry where this hazardous liquid has to be transferred from one place to the another place. Arrangement is like this. This is a P tank and this is a receiver here, and this in between feed tank there is a U loop is provided, and in between air is used for the transfer of liquid from this tank to this tank. So what happens initially, the liquid will fill here in this limb, and liquid level in this pipe will be up to this, and air is below up, this air is applied, and due to supply of air, so there will be formation of two phase mixture in this wheel u limb, and which has less density than the this pure liquid, and with the air help of air, this two phase mixture is lifted and is transferred to a vent pot where that air liquid mixture is separated from each other, and liquid is uh, uh, transferred to the receiving tank. This question is actually not related to fluid mechanics. It is a common sense question. Still, I have asked sometimes. I have noticed somebody general question they also ask. So there is argon cylinder, and this is a tank, and the tank has to be filled with pure argon. And how to do it? Somebody may say that you just open the valve and this you fill the tank, but there will be always some tracer of air will be there present in that. So another may give an answer that first you evacuate this tank with the use of a vacuum pump, and then you fill this tank with argon. But still, 100% evacuation is not possible. In any case, some traces of air will be there always present. So, in order to avoid that, generally what is done here, can be done here. This tank is filled with water, and then this argon cylinder valve is open, and this argon will replace or displace water, so that fill argon in this tank will have pure argon. Question number 14, determination of leakage rate in a pressure vessel. Generally, in process industry, any pressure vessel leak testing is done. So how to do it and how to calculate the leakage rate for a pressure vessel? Draw boundary layer and explain about it. In that several questions, sometimes they ask what is fully developed boundary layer, what is boundary layer thickness, and how to calculate it, what is a viscous layer, and what condition boundary layer, hydraulic boundary layer and thermal boundary layer become. Question number 16. Any idea about liquid seal? In sometimes a processor vessel has to be isolated from surrounding or any other process equipment. So this kind of arrangement generally used. So this is a process vessel, and there is a cup here, and this is a lead closing this process vessel. One may answer that flange can be used in order to close this vessel, but frequent opening of this flange will not be very much convenient, because sometimes it is
may be required frequently to open the lid to supply the feed material or any other liquid or in this vessel. So for that purpose, this kind of arrangement is used. This is a cup here, and it is filled with water or any other liquid. Should not react with this medium here, and a lid is just kept here on this cup, and it can be opened by manually by using any crane, or if it is a lightweight, it can be lifted by manually. Uh, this as previously we have discussed about constant header tank, and actually the two nozzles are there. One is top nozzle, one is bottom nozzle. But in tank it is generally welded one, and how to know which one is top nozzle and which one is a bottom nozzle. And question number 18. This is a, suppose this is a long cylinder, and a particle is flowing down under the action of gravity. Uh, our question is how to uh, draw velocity profile as a function of height, and at what time, what is the time required to reach the particle at the bottom of the cylinder. Another case is that instead of one particle, there is a two particle falling under the action of gravity, and in that case, time to reach particle will be same or different. And that's all today. In the next video, I may present some more question. So thank you for your kind attention.